Hello guys, welcome once more to another video in our YouTube channel. So in this video we are going to be looking at the Meetlearn practice examination of 2024, pure mathematics with mechanics paper 3, and we are going to be solving one of the questions. I think it was question 4, and it is from the topic center of mass. So I'm going to read the question, then we analyze together. The figure shows a laminar ABCDE where CD equal to 8A, DE equal to 2A, BC equal to 4A, and AB equal to 6A. Here is the lamina. A. Find the distance of CD and of CB from the center of mass of the lamina, 7 marks. The lamina is suspended freely from C such that CD makes an angle of theta with a vertical. Show that tan theta is equal to 43 divided by 85. A circular portion of radius B is cut off from the above lamina such that BC is tangent to the circle. Given that the distance of BC from the center of mass of the remaining portion of the lamina is A divided by 3, prove that 310A cubed equal to 3B minus A times pi B squared. So if this is your first time in this channel, I encourage you to subscribe to the channel. After subscribing, make sure you turn on your notifications so that when other videos are uploaded, you'll be notified to come and watch. Make sure you like the video at the end, you comment in the comment section, and you also share the video with your friends after watching. I would also like you to pause the question, try to solve, and see if at the end of the day my solution and your solution are going to coincide or are going to be the same. So without wasting much of your time, let's get started. Alright, so we are going to begin with the first part of the question. So we have the given lamina ABCDE, and we need to find the distance of the center of mass of the whole lamina from CD and from CB. So in the first part of this question, this circular portion is not considered. Anyways, the circular portion which was cut off is still part of the lamina. So we are more interested and concerned with finding the distance of the center of mass of the whole lamina, including the circular portion that is of the whole lamina, from the side CD and from the side CB. So the center of mass of this whole lamina will definitely lie at a certain point here, and its distance from CB will be a horizontal distance. We could represent it as X bar, and its distance from CD will be a vertical distance, and we can represent it as Y bar. Now we basically need to use the principle of conservation of moments, which says that the algebraic sum of moments of a system about any given axis is 0. We could also say that the clockwise moment about a given axis is equal to the anti-clockwise moment. That is the total clockwise moment equal to the total anti-clockwise moment. Alright, knowing fully well that moment is weight times perpendicular distance, and the weight is the mass times acceleration due to gravity. But this lamina has no mass. Alright, we don't know the mass of the lamina. So we are going to introduce a constant. We call it the mass per unit area. Mass per unit area because we can find the area of the lamina and of any portion of the lamina that we consider. So we let lambda be the mass per unit area of any portion of the lamina we consider, which means that lambda is a mass on the area of any portion. So the mass is lambda times the area. Now since the weight is mg, we replace m with lambda a, and then we get the weight to be lambda a times g. Alright, so the weight of every portion we consider in the lamina will be the mass per unit area lambda times its area, then times g. Okay, so we are going to create a table where we are going to divide the lamina into various portions. We find the weight of those portions, then we find the distance of the center of mass of those portions from CD, and from CB. So let us divide this lamina into various portions. Now we are going to consider portions that we can easily identify, shapes that we know. So I'll start by just indicating a vertical line here so that I have a rectangle here whose width is 4a and whose length is 6a. Now we are going to indicate a horizontal line here so that we have a right angle triangle and we have a rectangle. This right angle triangle will have a height of 2a and a base of 2a. Now the height is 2a. The height is 2a because the distance, this little distance below here is 2a, and the width of the the lamina, or the width of this rectangle here, is 4a. So the distance going up here is going to be 2a. Alright, so I can call this point F and I can call this point H. The distance from A to F is 2a. What about the distance from F to E? Since I know that from C to D is 8a and from B to A, which is the same as from C to H, is 6a, it therefore means that the remaining portion will be 2a, so that we add the 2a to the 6a to give us 8a. It therefore means that the base of the triangle is 2a. Okay, so these are the portions. We have the first portion, which is A, B, C, H. That is a rectangle. Now, what is the width of that portion? The width of that portion is basically lambda AG. A is all we need to find, the area. Since it is a rectangle, the area is length times width. So we multiply 6a with 4a, we get 24a squared. Now we multiply it with lambda g. So the area is 24a squared lambda g. Now, what is the distance of the center of mass of the portion we have considered from CB and from CD? Okay, so first of all, we need to locate its position of center of mass before we find the distance. Since it is a figure that has a center, then the center of mass will be at that center. Since this is the center, it means that if I leave from the center to CB, it is basically gotten by taking the length divided by 2. If I leave from the center to CD, it is the same as taking the width divided by 2, because this is the center. So this distance here, the distance, let's first of all start with the distance from CD. The distance from CD is the vertical distance, which is basically 4a divided by 2, which is 2a. We fill that in the table. Now, the distance from CB is a horizontal distance, which is 6a divided by 2, which is 3a. We fill that on our table. Now, we are done with that portion. So the next portion we are going to consider is a portion HDEF. This is actually a square because the length and the width are all the same. Okay, just that I've not drawn to scale, so you might think that this is bigger than this, but 2a and 2a means that it is a square. What is the area? Side squared. 2a times 2a is 4a squared. So the width will be 4a squared lambda g. Now, the position of the center of mass of this square is also at its center. Now, let us find the distance from CD. It is this vertical distance, and that distance is basically 2a divided by 2, which is a. Now, let us find the distance from CB. To find the distance from CB, we first of all start by finding the distance from the side of the square, which is HF. Then we now add the distance from HF to CB. Now, what is the distance from the center of mass of the square to the side of the square? It is basically the side of the square divided by 2. That is the length of the square divided by 2, or the side, because the length and the width of the square are all the same. So this little distance here, that is this distance, is 2a divided by 2, which is a. But we are not finding the distance from the center of mass of the portion to the side to FH. We are finding the distance to CB. So since this little distance here is a, this remaining distance here is 6a. It therefore means that the distance from this point right up till CB is 6a plus a, which is 7a. We indicate that in the table. Now the next portion is our triangle, which is AFE. It is a right angle triangle, so it has no center. It rather has what we call a circumcenter or an orthocenter. Its weight is half base times height, then lambda g, because the area is half base times height. The base and the height are the same, so when you multiply the base and the height, we have 4a squared. Then we take half of it, we have 2a squared. Then we multiply with lambda g. Like I was explaining earlier, a right angle triangle has no center. It has an orthocenter or a circumcenter. Okay, so the center of mass will lie at that orthocenter. Okay, and let us find the distance from the center of mass of this right angle triangle from CD. That is just from the line CD. Okay, so the required distance we need to find is this distance. Okay, that is the distance we need to find. But to find this distance, we will start by finding this little distance here. We start by finding this little distance. Okay, now this little distance is a distance from the center of mass of the triangle to the base, and that distance is 1/3 of the height by definition. So this little distance here is 1/3 of the height. The height is 2a, so that little distance will be 2a divided by 3. Okay, but the required distance we are finding is a distance in red, so we need to add that 2a on 3 to the distance from the base to CD, and the distance from the base of the triangle to CD is just the side of the square, which is 2a. All right, so when we add these two, we are going to have 8a divided by 3. Okay, now the next distance we need to find is a distance from the center of mass of the same right angle triangle to CB. So we need to find this distance, the distance from the center of mass of the triangle to CB. So to find that distance, it is preferable we start by finding this distance. That's the distance from the center of mass of the triangle to the height of the triangle. Then we add now the remaining distance that we take it to CB. Now this distance in green is basically the distance from the center of mass to the height, and the distance is 1/3 of the base. Okay, because it's a horizontal distance, so it is 1/3 of the base. The base is 2a, so 1/3 of 2a gives us 2a divided by 3. Now the required distance we need to find, we are going to take the 2a divided by 3 and then we add it to the distance from the height right up till CB. And the distance from the height right up till CB is 6a. It is the length of the first portion, so we need to add 6a. So when we add, we are going to have 20a divided by 3. 20a divided by 3. All right, so we are done with the individual portions we considered. Now we need to take the portion which is a whole lamina ABCDE. The weight of the whole lamina is the sum of the weight of its individual portions. So we add 24 to 4 and to 2, we get 30a squared lambda g. The distance of the center of mass of the whole lamina from CD is y bar, and the distance from CB is x bar. So that is it. So we have completed the table. After completing the table, we now need to apply the principle of conservation of moment. Okay, so from the principle of conservation of moment, we are going to take moment about the given axis. So we start by taking moment about CD. If I take moment about CD, I'm going to take the moment of the whole lamina about CD to be equal to the sum of the moments of the individual portions that makes up the lamina. So the moment of the whole lamina is just gotten by taking the weight times the perpendicular distance from CD, and the perpendicular distance from CD is a vertical distance, which is y bar. So we are just going to be considering all these distances from CD. So the weight is going to be 30 a squared lambda g times y bar equal to, we have 2a squared lambda g times 8a over 3 plus 4a squared lambda g times a plus 24a squared lambda g times 2a. Doing that, this is what we have. 30a squared lambda g times y bar equal to, we have the first portion 2a squared lambda g times 8 over 3 plus 4a squared lambda g times a, and then plus 24a squared lambda g times 2a. Now a common term, which is a squared lambda g, will cancel throughout. Now this is going to give us 16a over 3. Now this is 4, this is 48. 48 plus 4 is 52. So we are going to have 30 y bar equal to 16a over 3 plus 52a. 16a over 3 plus 52a will give you 172a divided by 3. So to get y bar, I will divide both sides by 30, and doing that, we just have to multiply this 3 with a 30 to get 90. So the distance of the center of mass of the whole lamina from CD is y bar equal to 172a divided by 90. You can further simplify to get your result. Okay, now we are going to take moments about CB. So taking moments about CB, we are now going to be interested with the distances from CB, because the distances from CB are the perpendicular distances. Alright, so if I take moments about CB, we are going to have the moments of the whole lamina equal to the sum of the moments of the individual portions that make up the lamina. So we have 30a squared lambda g times x bar to be equal to 2a squared lambda g times 20a over 3 plus 4a squared lambda g times 7a plus 24a squared lambda g times 3a. Now a squared lambda g will strike off all through. Here we are going to have 40a over 3. Here we have 28a plus 24 times 3. 24 times 3 is 72. So 28 plus 72 gives you 100a. So at the end of the day, we have 30x bar to be 40a over 3 plus 100a. The LCM and everything will give you 340a divided by 3. So what is the value of x bar? It's going to be 340 divided by 90. Okay, so the zeros are going to cancel and we get 34 divided by 9a. So the distance of the center of mass of the whole lamina from CB is x bar equal to 34 divided by 9a. Okay, now these are the previous informations we had. The question continues. The lamina is suspended freely from C such that CD makes an angle of theta with the vertical. Show that tan theta is equal to 43 divided by 85. So first of all, I would like us to draw what is happening. So there is a suspension at the point C. So it hangs like this. This is the center of mass of the whole system. Now you need to note that for the lamina to be in equilibrium after suspension, then the line that is joining the center of mass of the lamina to the point of suspension is supposed to be purely vertical. So it was suspended at C. All right, it was suspended at C, and for it to be in equilibrium after suspension, then like I said, the line that is joining the point of suspension to the center of mass of the system has to be a vertical line. So these are my points, and then now my center of mass is at G. So CG is my vertical. Now CD is making an angle of theta with the vertical. So note this condition, okay? So whenever you're suspending, note that from the point of suspension to the center of mass of the system, the line joining the 2 points is supposed to be a vertical line. That is your vertical. So the angle we are interested here is the angle made by CD with the vertical. This is CD and this is a vertical. So the angle is the angle theta. Now you realize that we could indicate some distances. The distance from the center of mass of the whole system to CD is this distance, alright, and the distance of the center of mass of the whole system to CB is this vertical distance. If you come back here, you see the distance from the center of mass of the whole system to CD, what is the distance? It is y bar. And the distance from the center of mass of the whole system to CB is x bar. So we are going to have that this distance from the center of mass to CD is y bar, while the distance from the center of mass to CB is x bar. But this distance here is the same as this distance here. So we can indicate the x bar there. That is the adjacent of the right angle triangle we clearly see here. So if I take tan theta, what would tan theta be? Opposite of the right angle opposite to the angle in the right angle triangle divided by the adjacent of the angle. So it is y bar divided by x bar. But what is y bar? Y bar is 172 over 90, and then x bar is 34 on 9. When we divide, the a's are going to cancel, and to change the division to multiplication, we have to just multiply with 1 over x bar, which is multiplying with 9 over 34. Now we can first of all simplify by just dividing this man by 2. If I divide this by 2, okay, and I divide this by 2, I will have 17 here. 9 is going to cancel. I'm going to have 10 here, alright, and then when we divide this by 2, we get 86. But here we have 10. We divide by 2 again. 86 on 2 is 43, and the 10 on 2 is 5. So simplifying, we just have this. So we multiply the numerators and multiply the denominators, and we have that the tangent of that angle is 43 divided by 85. So if there's one thing I want you to note here, is that when the body is suspended at a point and it is in equilibrium after suspension, then the line that is joining the center of mass of the body to this point of suspension is a vertical line. That is your vertical, and with that you can now get the other things. Okay, so we are done with question B. Let's move on to question C. Okay, now for question C, we have an instruction. What is the instruction? A circular portion of radius B. This circular portion is now involved. The circular portion of radius B is cut off from the above lamina such that BC is tangent to the circle. So the circle is touching BC at one point. Given that the distance of BC from the center of mass of the remaining portion of the lamina is A divided by 3. So when you remove this portion, there is a remaining portion of the lamina which does not contain this portion, and the distance from the center of mass of that remaining portion from BC is actually A divided by 3. We have to show that 310A cubed is equal to 3B minus A times pi B squared. So basically here we are going to consider a new table where we still know that lambda is a mass per unit area. Now we have the portions. We are going to consider the new portions. We have the new weight, and then the distance of the center of mass of the portions you are going to consider from CD and from CB. But since according to the equation CB and BC are the same axis, so according to the equation they gave us just the distance of CB from the center of mass of the remaining portion of the lamina. So we are not going to consider the distance from CD, alright, because when we are taking moments, we'll just take moments about CB. So the first portion, we are going to consider the whole lamina. Okay, the whole lamina, we have the weight already, and its distance from CB is x bar, and x bar we found was 34a divided by 9. The weight of the whole lamina, we saw it previously, was 30a squared lambda g. Now the other two laminae involved, the first one is the circular portion. The circular portion is what was removed. Now this circular portion has a weight of the area times lambda g. The area is pi radius squared, where the radius is b, so the area is pi b squared. So the weight is going to be pi b squared times lambda g. The center of mass of this circular portion is at its center, okay, and the distance from the center of mass of this circular portion from BC is just this distance, and that distance, since BC is tangent to the circle, then that distance is the radius of the circle, and the radius of the circle is b, so that distance is b. Now the remaining portion of the lamina, the weight is gotten by taking the weight of the whole lamina minus the weight of what was removed. From these two weights, lambda g is common, so we could just factorize lambda g, then we take 30a squared minus pi b squared. The distance from the center of mass of the remaining lamina from CB is a horizontal distance. We can call it a divided by 3 because it was given already in the equation. We don't need a distance from CD, all right, we just need a distance from CB. So the whole lamina, the remaining lamina, has a distance of a over 3 from its center of mass to CB or to BC. Okay, we are now going to take moments about CB. So taking moments about CB, we need to take the moment of the whole lamina to be equal to the moment of what was removed, because what was removed is still part of the lamina, then plus the moment of what is remaining, because what was removed and what is remaining are basically part of the whole lamina. So it therefore means we are going to have 30a squared lambda g times 34a on 9 to be equal to pi b squared lambda g times b plus 30a squared minus pi b squared lambda g times a divided by 3. Now what is common throughout is lambda g, so lambda g is going to cancel. Now when lambda g cancels, we are going to multiply all through by 9, okay, and divide all through by 3. I think, is that what I did? We multiply all through by 9 and then we divide all through by 3. If I multiply all through by 9, this is what we are going to have. Basically, when we multiply all through by 9, we are going to have here 30a squared times 34a. Okay, so let me just try to write back what we have. So here is supposed to be 30a squared times 34a, which will give you 30a cubed times 34. When I multiply this quantity here by 9, now b is going to be cubed, and in the place of 3 we actually have 9. Now when you multiply this quantity here by 9, 9 divided by 3 will give us 3, so there's going to be a 3 here. You realize that we can now divide all through by 3. So once I divide this by 3, what is going to happen is that the 3 is going to cancel and we are going to be left with 10. Once I take 9 over 3, I'm going to be left with 3, and once I take 3 over 3, I'm going to be left with 1. That is why I just keep that step. So I had 10a cubed times 34 equal to 3 pi b cubed plus 30a squared minus pi b squared times a. Now if I expand, 34 times 10 is 340a cubed equal to 3 pi b cubed. Now a times 30a squared is 30a cubed. Negative pi b squared times a is a times pi times b squared. We bring like terms together, we subtract 30a cubed on both sides. 340 minus 30 is 310, so 310a cubed equal to 3 pi b cubed minus a pi b squared. From these two terms, pi b squared is common. If I factorize pi b squared from here, I'll be left with 3b. If I factorize pi b squared from here, I'll be left with a. So at the end of the day, we have that 310a cubed is equal to, so this is what we have, 310a cube is equal to 3a, 3b minus a, all of that multiplied by pi b squared. And we have come to the end of the video. So if the video was good, make sure you like the video like I said at the beginning. You subscribe to the channel if you're just new. If you want to prepare for preparatory classes, if you want to prepare for concourse via preparatory classes, you can contact me directly and I'm going to give you more information about that. Alright, see you guys in the next video and thank you for always being there.